Greetings all. Tonight, dogs are going after something different than Rosette Nebula. Greetings all. Tonight we're going after the Rosette Nebula. Now the Rosette Nebula is about 5,000 to 5,200 light years away from Earth. Now sometimes the Rosette Nebula is referred to as the Skull Nebula because supposedly it looks like a skull, but I never saw that. Now the Rosette Nebula is an emission nebula out in the constellation of Monoceros, also called the Unicorn. It's over near Orion, and I'll show you how to find it in the night sky here in a little bit. Now some of you might be wondering, why am I not wearing my standard shorts and t-shirt? Well, I'll tell you, it has done got stupid cold here. Right now it's down to right around 50 or 51, and then tonight it's even going to get down close to freezing. So it's going to be a really cold one out there tonight, but it's supposed to be really clear too. So we'll go ahead and tough it out and see what we can get on the Rosette Nebula. You'll see that tonight we're using this William Optics Z103 APO doublet up on top of the iOptron CEM60. Notice up here, what's behind all that gray tape? I've got 4 dew heaters on there. It's been really humid, and I've been having problems with dew on my lens. So I've got 4 dew heaters on there, and I put that tape on them to keep them all bunched up. So hopefully I can keep the dew off of the lens tonight. Notice I routed the cords back along here, tied them onto the telescope, and then they come right down off of the stem. Now this way I'm not dragging around a bunch of cables to cause balance issues. So hopefully that's going to help out with the guiding. And you see my dew heater controller where I've got all 4 of the dew heaters plugged in. Coming on back here, right here you see the William Optics 0.8 fill flattener. You also see that I've got a adjustable ring on it. So it's a spacer, adjustable spacer, so you can achieve the proper distance between your fill flattener and the camera sensor right back here. It's important to get the right space in between there, because if you don't, then your stars just aren't going to look right out at the edges. I've got the ZWO Off Axis Guider on here, and for the guide camera I'm using the Starlight Xpress Lodestar X2. And then all the way back on the back we've got the ZWO ASI 1600mm Pro. Since it's a monochrome camera, I have my filter wheel here. It's an 8-position filter wheel. So tonight I'll be using my narrowband filters, hydrogen, oxygen, and sulfur. I might shoot some broadband later on to get some good star color, but tonight the moon is out very bright, so we're going to be shooting narrowband tonight. Anyhow, that's the setup. It's going to be really cold, so we'll see what we get on the Rosette Nebula. Okay, here we are in stellarium, ready to get going on the Rosette Nebula. We are polar aligned. The camera just finished cooling. It didn't have very far to go. It was pretty cold out here. Anyhow, I'm going to show you how to find where the Rosette Nebula is in the night sky. You won't be able to see it just with your eye, but with a small telescope, maybe even some binoculars, you'll be able to pick it out. Of course, here sits Orion right here. Betelgeuse up at the end, that's real easy to find. Sirius, the brightest star in the night sky, that's easy to find. And then Procyon over here is really easy to find. So those 3 really bright stars. Now you just got to find one more. And it's this star right up here. It's not as bright as the others, but in the night sky you can see it really good. And what you're looking for is you're looking for a cross. So for this star, you come down to Sirius, and then from Procyon to Betelgeuse going across. See, you see how that's a cross right there? Just like that. And then the Rosette Nebula sits like right here under the left armpit of that cross. So if we zoom in right here, you see it right there. So that's how you find where it's at in the night sky. So back it out again and let you look at it. So here's the cross right here, and then the Rosette Nebula sits right there under that left armpit. Now for our navigation plan, we're going to go from the North Pole where we are. We're going to do a long swing around here to Betelgeuse. We are going to do a focus and mount synchronization on Betelgeuse, and then from there it's just a really short hop on over to the Rosette Nebula. So let's make that happen. So off it goes from the North Pole over towards Betelgeuse, just like we told it to do. And notice it's looking over on the east side of the meridian. That's because the Rosette Nebula just came up not too long ago, and it hasn't crossed the meridian yet. So it's still on the east side of the meridian.
Exposure started. Exposure finished.
Notice Betelgeuse was not there. That's okay.
Exposure started.
It knew where it was at. It did a quick
Exposure
adjust. And Betelgeuse is going to be here this time. There it is.
Go to plus finished.
That's the beauty of plate solving right there. It's so easy. So we'll synchronize the mount. Now the mount knows that it's looking at Betelgeuse. Let's go and take a peek stellarium just to confirm. Yep, there it is, just like we thought it was. All right, now that's done. We'll double check our focus here. All right, we're focused. Take the batten mask off and we'll go find our target. All right, so we're looking for the Rosette Nebula. Go in our deep sky tab here. I'll type in Rosette and see if we can find it. There it is right there. All right, off we go. Now it doesn't have to go very far, so it may find it on the first try. If it doesn't, probably just have to make one adjustment, then we'll be there.
Exposure started. Exposure finished.
Yep, this is it right here. That's the center of the Rosette Nebula right here. This is going to make a small adjustment.
Exposure started. Exposure finished. Go to plus finished.
Now, I'm going to go ahead and center, get centered right down here in the middle of it. So we'll just use it. I'll go ahead and sync them out here. Now I'll just use the aim function just to get right down here, kind of in the middle of it. It's a quick adjustment, and now you'll see that we're going to be right in the middle of that clump of stars.
Exposure started. Exposure finished. Go to plus finished.
All right, let's synchronize the mount. Take a look in stellarium and see where we are. Yep, right there in the middle, just like we wanted to be. I like that framing. Looks like we're just fitted all in there. So I'm happy with that. I don't think we need to adjust it anymore. So we'll get some guiding going. I got a bunch of good stars to choose from. Let's go with this one right here. That looks like a good one. It's going to calibrate. You see down here, it's going to west step. It's going to count it all the way up to 26, and then it'll count it back to 0, and then it'll do north and south. But while it's doing that, we'll take a look at our imaging plan. I'm going to shoot this in narrow band, so Let me find I think I've got a narrowband target here, narrowband planned here already. Let's edit this one. Okay, so there it is. Notice we're doing 10-minute exposures. So we'll do 8 of HA, 8 of O3, and 8 of S2. So if I do that math right, that's what, an hour and 20 minutes on each one of these filters, and then after that we'll just crank away 2 at a time and till the night's over. So we're all set. We're guiding. Let's take a peek at our guiding. It seems to be doing okay right now. We come back and look at it later if we need to. But let's get the pictures going.
Filter change. Exposure started.
I almost hate to say it, but that was almost too easy. Nothing went wrong tonight. It all worked out. I like this night as long as it keeps going like that, but I just hope I didn't jinx myself. But we'll have the first indication here in about 10 minutes when the first picture comes in. We'll take a look at it together. Yeah, first image is about halfway done, but I thought I'd come back and show you the guiding here. Total RMS error, we're running at 0.59. It has been down as low as 0.5. So I'm pretty happy with this guiding. Just hope it stays that way rest of the night. You see we got another 200 seconds till our first image comes in. Okay, I fast forwarded time, so our image is coming in here in about
exposure finished.
Right now. Let's watch it come in.
Dithering started.
There it is. How about that? How about that? I got to tell you, I like what I see. I like what I see. I'm a little bit surprised, to be honest with you.
Dithering finished. Exposure started.
You know, I was wondering if my telescope was going to be able to hack this frigid weather. And so far, I've got really good guiding down here. And I think this is one of the best single exposures that I have taken. So I guess my worries were all for naught. My equipment seems to be dealing with the cold weather just fine. And I can tell you far better than I am. I'm about to freeze. Anyhow, I'm going to let this run. The next event that we have, you see right here, we have a Meridian Flip in 152 minutes. That means 10:06 to me and you. 152 minutes, Meridian Flip. And if nothing goes wrong, I'm just going to let it run until then. We'll come back close to the Meridian Flip, and we'll see what the O3 and the S2 frames looks like. All right, here comes our first O3 frame.
Exposure finished.
Let's watch it come in.
Dithering started.
There's not much there, but I can still see some good definition around here. Nothing like the hydrogen signal, but there's still a lot of good stuff here. Also, if you watch my right ascension declination video, then you're probably wondering, well, where is the Rosette Nebula in relation to the Meridian? Let's take a look at that. Here's north. If we go north straight up through Polaris, straight up over our heads, curve back around to the south. Here's the Meridian line right here, going right up like that. So you see that the Rosette Nebula circling around like this. It's approaching the Meridian. Let's take a quick look at how long before it gets there. 56 minutes until it gets to the Meridian. Well, let's see if we can tell anything from that. We already said here, right here is the 6:33 hour line. Well, the Meridian, 5:06. So the Meridian sits here at right at 5 hours 30 minutes. So like we talked about before, it takes 1 hour for 1 hour of right ascension to move around the clock there. So since 5:30, 5 hours 30 minutes is the meridian right now, and the Rosette Nebula sits at 6 hours 30 minutes. It's going to take an hour for it to get around there to the meridian. See how that works? And then that's confirmed right here by our Meridian Flip clock. All right, now let me show you something. The meridian comes straight up out of north through Polaris, right up here. It's this right ascension line right here. So you see that the Rosette Nebula is right on top of the meridian now. It's just about to cross over the meridian. Now, let me show you what that means for our telescope. All right, you see here how the telescope is pointed straight up, right up at the meridian, and look how it's kind of gone sideways there. And if you look down here, you'll see that there's no more room for it to move. In fact, it's about to run into the pier down there. So the telescope just can't track anymore. So what it's going to do is it's going to flip around onto the other side of the pier so that it can get back going the other direction. So let's watch it go here. There it goes. Watch how it's going to swing around to the other side of the pier now. Now, what we have to pay attention to while it's doing that is that none of these cables get snagged up down here, which sometimes they do. So you see how the telescope is swinging around now there to the other side of the pier? See how it swung around there? Now it's pointed back where it was. But now it's got the whole way around to go again. So it can run for another 6 hours, 12 hours, something. It can run for a long time now before it has to swing around again. Anyhow, that's the Meridian Flip. It has to swing to the other side of the pier because it runs out of room. Now that it's gone over here, we've got to go and find the target again. Once we find the target, we'll do a refocus. We'll also have to recalibrate the guiding because we're on the opposite side of the pier, and then we'll get our imaging plan going again. Okay, I'll show you how we're going to get going again. We're on camera, 1 second exposure. We want to go back to the luminance filter to do our plate solves. So we'll switch that filter back to luminance.
Filter change.
Because we can plate solve with a shorter exposure that way. Yeah, Betelgeuse will be fine. Because you see, here's the horizon. Sometimes, like if I went and chose the star Procyon to do the next focus and mount synchronization, then you see that Procyon is back on the other side of the meridian that we just crossed over. So the telescope would have to swing all the way back around on the other side of the meridian to focus on Procyon, and then we'd have to cross the meridian again. So when we do this second focus and mount synchronization, we want to make sure we pick something that's on the west side of the meridian. But Betelgeuse is on the west side, so that's going to be fine. Okay, our focus is done. We are ready to get back on target, begin the rest of our plan. Yeah, you see, there's those stars down there that we got in the middle of before. All right, we'll synchronize the scope. Now the mount knows where it's pointed. Now we need to get right up in the middle of these stars. So we'll use the aim function to do that. About right there. All right, let's take a look in Stellarium and see where we're at. We're right where we want to be. You hear that? It's a coon fight. The owls and the coons are going nuts out there. Anyhow, we're back on Rosette Nebula. Get our guiding going. We'll have to recalibrate. Let's try that star right there. Well, you know what? I didn't recalibrate, but that looks okay. In fact, that looks real good. You know what? I'm not gonna recalibrate. I'm just gonna let it run and see if the guiding stays okay, and if it does, then I'll let it go.
Exposure started.
All right, we're off and running on the other side of the meridian. See, the next meridian flip is not going to happen until 10:05 in the morning. So yeah, it is 12 hours. It's 12 hours per side. I guess that makes sense. It's just 24 hours in a day. So this thing, this can run the rest of the night just like it is. I will be out here though to look at the first sulfur frame with you that comes in. So back in about 20 minutes when we get our first sulfur frame. All right, you just got a couple of S2 frames in. You see one of them called up right here. Not a lot there. There is some signal right around here. You can see it down there, a little bit up here. When we stack a bunch of these, there'll probably be enough signal to contribute. Anyhow, I'm quite happy with these. I think we're going to get a good night, maybe one more night, and we'll have enough to finish this up. So if something else important doesn't come up, then I will see you at the end. Greetings all. Tonight we're going after the Rosette Nebula. Now the Rosette Nebula is an emission constellation. Greetings all. Tonight we're going after the Rosette Nebula. Now the Rosette Nebula is an emission constellation out in the